Google. The search engine that was created almost 3 decades ago and continues to be the most popular search engine used today, no matter how much Bing tries to convince you otherwise. You all have used Google before and it needs no introduction. But have you ever wondered how it actually works? Hello, I'm Mults, and if you're watching this video it's because you're a nerd. But so am I, and I made my own Google from scratch. You probably already know why because it's in the title of the video, but I'll tell you anyways. I'm in my last year of my bachelor's degree and I haven't managed to get a job or an internship, and I don't want to be cooked by the time I finish my master's in 2 years. So I decided to make a cool project to show companies what I can actually do. So in this video, I'll tell you how I made my very own search engine from scratch. And I mean from scratch. We're back in the 1990s, so no AI bullshit, no pre-made web datasets. I'm browsing, processing, and indexing the internet just like Google did back in 1996. If you're not familiar with the term, a search engine is a system that allows you to search for documents on the web. Based on that, you may think that it's just a simple web application with some HTML, CSS, and JavaScript, but it's not quite like that. This here is the architecture of a basic search engine. Normally, this is the part where I would make a badly drawn diagram and put a bunch of anime gifs, but today, we're making a serious video, guys, so we're in serious mode now. Anyway, here's a Sonic GIF. The architecture of a simple search engine is fairly straightforward. There are 4 main components you need: a spider, an indexer, a query engine, and a client. The spider, sometimes known as a web crawler, gathers all the pages it can from the internet and stores their data to be processed later. The indexer organizes the data the spider collected so it's easier to search for relevant pages when you input a search query. The query engine processes whatever the user inputs and searches through the collection of indexed pages. And finally, the client is just the pretty part of the system. This is the main web page that the user sees and uses to interact with the system. And this is all you need to build a very primitive search engine. Nowadays, search engines are a bit bloated with big data, machine learning, blockchain, artificial intelligence, and many other useless things like that. And while I do think that using AI in a search engine can be useful, particularly for natural language processing, I do not want to use it because I'm saturated of the AI bubble. Everything has AI nowadays. I'm sorry, but Notepad has no reason to have fucking Copilot integration. Besides, you can still make a good search engine without using any AI. However, in order to do that, I need to add some more components to the basic architecture I just described. The type of architecture you see here is referred to as a distributed systems architecture. The important thing to notice is that this means that each one of these components is independent from the others, and that allows for a bunch of useful gimmicks that I'll mention throughout the video. So just keep that in mind for now. The first important gimmick, I don't know why I'm calling it a gimmick, is that since the components are independent, I can write each one of them in a different programming language. And that's the challenge I set myself to do. I never get to try different programming languages, so I thought it might be fun. And to change my content style a bit, I decided to use a 5 JavaScript rating system when talking about the parts of the search engine that I developed. Here, 5 JavaScripts mean I suffered a lot working on this and that was the most awful shit I've ever done, and 1 JavaScript means that was pretty meh. You may wonder why in that order and not the other way around. Well, because I hate JavaScript, so the more JavaScripts, the more I suffer. So now, I'll use my greatly trained mid-tier YouTuber abilities to explain to you how all this works in a silly and fun, but hopefully also educational way. And if all that fails, I'll just put a bunch of anime gifs and swear a lot. That usually works as well. To understand why we need a spider, you need to think about how people used the internet before search engines got popularized. See, thousands of years ago, people had these things called phone books. So when the internet became a common household thing, humanity's first instinct was to make the same thing but for web pages. Some of you may think that I'm making this shit up, but I'm not kidding. I happen to have a copy of one of those old books. Can you imagine having to use this whenever you wanted to search something? I would rather kill myself. With that said, the point of the spider is to collect all the pages that exist on the internet like this phone book did, and store their data so we can organize it later. And how does it do that? Well, it's quite simple. You give the spider a starting URL. Then you fetch the data of said page and look at its source code. In this case, the HTML content. By looking at the code, you can collect all the links you find in the HTML tags and put all those links into a queue. Then you repeat the same process by popping the next URL from the queue. This will continue until you run out of elements in the queue or until you stop it. Now, if you've never touched graphs before, you'll notice 2 things. First, this is just a graph. Second, what I describe is just good old BFS. Now, for the people who do shower, BFS stands for breadth first search, and it's one of the most common tree traversal algorithms in computer science. So who would have thought? Data structures and algorithms? Kinda useful. But Mults, why BFS and not DFS? Good question, my favorite viewer. What do you think? I'm talking to you. In simple terms, BFS allows the spider to gather a broader range of categories with less pages scrolled while also prioritizing more important pages. Now let's talk about something a bit less cringe. Which starting URL did I choose? Ideally, you want to choose important pages that either get constantly referenced and or have a ton of references. This includes things like Wikipedia, news pages, blogs, and other things like that. I decided to make a couple of tests with some Wikipedia entries, and my favorite one to start with was Kamen Rider, a very old tokusatsu TV show from Japan. and you may recognize this guy because I put it in every single one of my fucking videos. Starting from Kamen Rider, the spider was quickly crawling pages like Godzilla, World War II, communism, and Romania. Well, maybe I should have picked a better starting URL. I could talk about this spider for a whole day because there was just a lot of stuff to do and I refactored this codebase like 20 times. But instead, I'll keep talking about it for like 2 more minutes because I spent God knows how long working on this and it's my channel, so I get to do whatever the hell I want. Besides just going through the pages using BFS and storing the raw data, there are 3 other things the spider has to store to make a more useful search engine. And those are outlinks, backlinks, and images. The backlinks of a page are all the links that take you to that specific page, while the outlinks of a page are all the links that take you from that specific page to other pages. This may seem arbitrary to store, but knowing the backlinks and outlinks will be used to determine which results will be shown first to the user. I'll talk more about it in a bit. Storing images is not needed for any optimization purposes. In fact, it only makes it worse for me, but a good search engine that doesn't allow you to search for images might as well just be a bad search engine that doesn't allow you to search for images. Sorry, I couldn't think of a joke for this part. Anyways, in order to do that, similarly to the links, whenever we find an image tag in the HTML content, we just get that image URL and store it in reference to that page. The whole process is a bit more convoluted than this, but I can feel their attention going down, so I'm just gonna move on. I coded the entire spider in Go, and you may think that that's because Go is a very fast but also memory-safe language with a very intuitive way of implementing multi-threading and a goofy-ass mascot. And that's pretty much why. Finally, I have to give the spider 4.5 JavaScripts out of 5. It was fairly okay, I enjoyed it a lot. I had never worked with Go before, so I had to learn a lot of new things, but honestly, Go is kinda goated. That was so bad. But the fact that this is such an important part of the project meant that I had to rewrite and refactor the code multiple times, and I don't want to work on it anymore. Algorithms, web development, new programming languages, coding in general. All those things can make a lot of new developers quite stressed. But turns out you can actually learn stuff like that without digging through 20-year-old programming books or rage quitting halfway through a lead code problem. That's where Coditech comes in. It's like Duolingo, but for coding. You get these structured journeys that guide you through real programming topics like algorithms, data structures, and how to learn JavaScript so maybe you don't hate it like I do, all in tiny bite-sized challenges. Perfect for when you're waiting for your application to compile, or for when your brain is too fried to do anything else. It's got loads of things. A strict system, a good AI tutor with a proper system prompt to help you learn. You know I hate AI, so if I don't hate this one, that means it's good. And a ton of challenges to gamify your learning experience, which is great because I know you need the dopamine due to all the brain rot nowadays. And the best of all, if you don't want to pay for it, there's a daily free usage limit. You can try it right now, suffer through some dynamic programming without crying, finally figure out what a Go routine is supposed to do in Go, or just vibe with some JavaScript until you start questioning your life choices. So go check it out, links in the description. And if you're a fellow broke CS student like me, this may actually help you for the interview grind. Now back to me suffering while building the rest of this stupid search engine. Good news, the worst part is already over. So even though I have 4 or 5 more sections to talk about, they are definitely not as lengthy as the spider section. Bad news, this video is pretty long, so you're stuck with me. Once the spider has done its thing, we'll have a bunch of pages in our database, which is cool and all, but what the fuck do you do with that? Well, as I mentioned, I don't know how many minutes ago, the indexer is the one thing in charge of organizing all the pages the spider has gathered. And here's how it does it. First, it takes one of the gathered pages and look at its HTML code that we already had saved. Then it does some Python shenanigans to get only the text in the source code. Yes, I'm using Python for this service, I forgot to mention that. After that, it performs some more Python dark fuckeries to remove all the useless words such as connectors, prepositions, and symbols, and creates a map of all the words in the page, where each word is paired with its frequency. We'll call the frequency the weight. Finally, it iterates through all the elements in the map and appends the current URL to each word entry in the database along with its respective weight. So at the end, we'll have something like this. A couple of word entries where each word stores all the URLs that contain that word, along with a weight that represents how many times that word shows up in each URL. Now for the people who are gonna be like, actually that's not how you do an indexer, you need to do this and blah blah blah, shut up. This is the first version. I'll talk about an improved version later in the video. Indexing images works in a very similar way, except that defining the weight of the images is slightly different. I would explain to you how it works, but I do a little thing called vibe coding, which, if you haven't been on Twitter, it means that I drink a shit ton of Monster, I blast some J-pop, I code until 4 AM, and then I pass out and don't remember how my code works afterwards. I give the indexer service 2 JavaScripts out of 5. This was very easy to make, and besides some minor refactoring, it stayed the same the whole time. Also, Python is very easy to work with, and there are many libraries to do the things I need to do, so good time overall. All the previous stages were just pre-processing. Now is where we actually start seeing some results in the search engine. As I mentioned at the beginning of the video, the query engine is in charge of processing whatever the user inputs and fetching relevant results for that query. For example, if a user searches for Hatsune Miku x Godzilla, what the query engine will do is to split this phrase into words. For simplicity, we'll pretend like the X does not exist in this query. Then it will iterate through each one of these terms and fetch the page's index for that term from the database. Let's say the term Hatsune has the following pages, Miku has these pages, and Godzilla has these other ones. As you can see, the Reddit post that talks about Hatsune Miku and Godzilla is the only page that overlaps among all our terms, so naturally, we'll choose to display that one first. Since the other pages don't fully overlap, we can choose to either not display them, which may not be useful from a user experience perspective, or to display them but rank them lower, which is what I'm doing. In case there is more than one page overlapping, an easy way to decide the order in which the results are going to be displayed is by checking the cumulative weight of each page. Ergo, just sum the weights of each term for a specific page. Again, ranking images works in a similar way. Now I know a lot of you might be thinking, but Mults, this is not how Google works, you haven't implemented the PageRank algorithm properly and blah 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 blah. I know, but explaining a simplified version of it makes it way easier for me to add more complex stuff later in the video, so just be patient. Coding the query engine was more fun than I was expecting, and that's most likely because I didn't use JavaScript. I used Laravel, a PHP-based framework that is actually cool to use. And since I was gonna use JavaScript anyways for the frontend, and I hate frontend more than I hate JavaScript, this was the best choice I could make. I always thought I sort of hated web development, but I think I didn't hate web development. I just hated JavaScript. That being said, I'll give the query engine 2 JavaScripts out of 5. I did run into some issues, but the documentation for Laravel is overall pretty good, and in the end, I was able to fix them. Okay, if my estimations are correct, I've been talking for about 12 minutes now, which is more than what my videos usually last, so if the editing is kinda rough, you know why. This project was way more ambitious than I realized. Anyways, besides the client, which I'm saving for the end because it's the most visual part of the project, what we have until now is more than enough for a basic search engine. But enough means shit if you're trying to get a job, so there are a few things we need to change. The next few sections will talk about things that I think are very interesting, but I wasn't sure if the general YouTube audience would find interesting. So I deliberately chose them to put them at this point because hopefully, I already have your attention by now. I spent a bunch of time working on this video, from the project itself to the script to the editing, and this is actually the 5th version of the script. There are a lot of things that I got rid of for the final version because they were not very interesting or they were just difficult to showcase in a fun way. So if you'd like to see the previous versions of the scripts with all the unedited things and also some extra content, you can become a channel member. Anyway, the next things I want to talk about are scaling up services, optimizing the spider, optimizing the indexer, creating a scaling service, implementing spell checking and a reverse proxy for the query engine, and finally, implementing the famous PageRank algorithm that Google uses. So let's just get into it, it shouldn't take that long. As you may have thought, or not, I don't know what's going on in your brain, having just one spider and one indexer is probably not enough to crawl this whole mess that we call the internet. Luckily for us, a very useful thing about distributed systems is that we can run multiple instances of the same service at the same time. So instead of having just one spider crawling the web, we can have a shit ton of them doing it at the same time. And the same goes for other services. Which is perfect because this means that if your computer is not powerful enough, you can just run a bunch of spiders in other computers. This is called horizontal scaling, and companies usually do this with clusters of servers in the cloud. But this brings up another issue. If the services are all running on different machines, how do they talk to each other and synchronize? We don't want the spiders to crawl the same pages multiple times. To fix this, I'm using Redis. In simple terms, Redis is a database that works in RAM instead of disk storage. The reason I'm using Redis is because it allows me to have different message queues that the services can access to synchronize with each other. So remember the queue I mentioned for the spider? Well, now each spider accesses a remote message queue in Redis. This helps reduce the possibility of crawling the same links multiple times. There are other message queues for other services, but it is not necessary to explain them for this video. The other thing I need to mention is that to actually store data that will be accessed later, I'm using MongoDB, a NoSQL database. So in this system, Redis is used for communication between the spiders and the indexers, and also to store some temporary data, but then all the important data is stored in MongoDB, which is what the query engine will access. With that being said, I decided to deploy my spiders in the cloud. And by cloud I mean this computer that I stole from the trash that I'm using as a server. See, all the previous points about horizontal scaling and distributed systems were pretty much useless since I don't want to pay for cloud. However, I did design the system with that in mind, so I should perfectly be able to run all these components in a distributed way once I have the resources. There is one small trick that I used to improve the spider. I changed the spider queue to a priority queue. Why? Because it made sense to me. Here, if a link is being referenced by a ton of pages, it must be important. And if it's important, I want to process it earlier. So if a link is added to the queue more than once, its priority will be increased. Currently, the way the indexer works is very rough and prone to errors because I'm not really evaluating the importance of keywords. I'm just counting individual words and using them as weights. The easiest way to fix this is by implementing the TF-IDF approach, which stands for term frequency inverse document frequency. This basically means that instead of just using the frequency of a word to calculate the weight of it in a page, term frequency, we also have to factor in how frequent that term is among all documents, inverse document frequency. Then the final weight of a word in a given document will be given by the following formula. This helps prioritize words which are frequent in a particular document but rare among all documents. Now to do this, I need to do 2 passes over the data, but let's not mention that. I used Rust to make a little scaling service that automatically scales up and down the number of spiders, indexers, and another service that I didn't mention due to time constraints based on the current load of the system. I was going to explain how this works, but I changed the code since then and it doesn't work anymore. Picture this. A bunch of users try to use the query engine at the same time. What happens? Best case scenario, the system slows down. Worst case scenario, the system crashes. That's why popular sites usually include some sort of reverse proxy, also known as a load balancer. A load balancer is an intermediate layer between the user application and the service that allows to redirect traffic to different instances of the same service so that the system doesn't collapse. Now this is just a fun prototype I wanted to make, so I don't expect this to be used as much as Google or DuckDuckGo, but in the remote case a few more users decide to use my search engine, I have to be prepared for that. And this is very easy to do if you use Docker because you can Dockerize your backend, in this case the query engine, and just assign a couple of instances to redirect traffic using Nginx so we can handle a greater number of users. Another improvement for the query engine is to introduce some spell checking. To check for spelling, I just had to implement a middleware in the query engine that will take each word the user inputs and compare it against a dictionary of words using the Levenstein distance algorithm to see how similar the words are. Luckily, this function is already implemented in PHP, so I didn't have to do anything. I just want to say that I also changed the code here since I recorded this video weeks ago, and the current spell checking is kind of shit. Also, I'm no longer using Nginx. I'm using Caddy, but whatever. The PageRank algorithm, the backbone of Google and the reason why it became so popular. The truth is that no one really knows how the current algorithm works, but the one that is publicly available is the one that was used back in the day, so it should be more than enough for a DIY IKEA search engine like this one. PageRank works in a simple but smart way. It uses the backlinks of a page to determine how important that page is and assign it a score or a rank. Because in theory, the more important a page is, the more pages will reference it. But as you may think, this is not the best approach because I could make 5 million fake pages that point to my page and it will rank higher than other pages. This is actually something people used to do back in the day to hack Google's ranking system. So in PageRank, the rank of a page is determined by how many important pages reference that page. But you may wonder, how do we determine if a page is important? Well, math. I would explain how it works, but I don't want to bore you with the details, so here's a good video explaining it. Because why should I do it if somebody else did it better? That's probably not a good advice, but my poor computer can't handle rendering more animation, so whatever. To calculate the rank of each page, I made a separate service using Go. I know I said I was gonna make each service in a different language, but I already use Go, Python, Rust, PHP, and JavaScript, which is more than enough. Don't blame me, I'm lazy. When a rank is calculated, it is simply stored in a separate entity, so the query engine can access it later. So to determine the order in which pages are gonna be displayed, we have to check the rank of each page. I give the PageRank service 2 JavaScripts out of 5. It took me a bit to properly understand how to implement it. I misunderstood it at first, but it works, and that's all that matters. Finally, we made it, the moment where I actually showcase how the app looks after all the suffering I went through. Currently we have a bunch of data in our system, but what's the point of having useful data if we can't display it in a pretty way? That's where the client comes in. Since I don't want to mess around with frameworks, I made a client using basic HTML, CSS, and JavaScript. I really wanted to go for a retro Y2K look, you know, back when the internet used to be fun and colorful, and I think I sort of managed to do it. Maybe it looks ugly, I don't know. I even stole this scanlines effect from this page to add some more flair to it. So thank you GitHub user who followed me. Now let me introduce you to Moogle. And yes, it is Moogle because I'm Mults and I made Google. I'm not original, I know. Now you may be wondering, what features does Moogle have? Well, you can search the web, you can search images, and you can avoid having your data stolen by other companies because I will do it instead. I'm kidding, I'm not stealing your data. I don't know how to do that. I would if I could, but you should be thankful I'm not smart enough. Now I don't know how to showcase it, so here's a compilation of my friends trying it. Can you stream, Adrian? Is that okay?
Me?
I mean, you opened the app, no?
Yeah. Fine. Do I have to use
Go to private window so you don't stay.
Yeah, you have to use Moogle is the whole point.
What do I search for? In Google, I would search for Fortnite.
Before anything, let me tell you that the algorithm to like index the results is still working. So some of the results are not gonna be accurate at all. Because I think it's going in like, I think I'm currently indexing words that start with L or something. I haven't looked at it in like an hour. Yes.
League of Legends?
I don't know if I have anything League of Legends related. And you're not typing.
Let's find out.
It found. Do you mean League of One Legends? No, I didn't, but it found the thing. Damn, this works.
See?
Esports.
Riot Games.
I told you. Look for an image or something.
The letter F doesn't exist yet.
I mean, just the letter. Tale of Kudam.
That is for sure a League of
What the fuck is
Legends.
this?
No.
I have no idea.
Wait, scroll down.
Yeah.
There's a Batman one. Scroll down a bit more. Does Batman work better alongside his allies or alone?
That has to do with League of Legends.
It does have to do with League of Legends.
Check for anything else. I want to show you something.
Anything else?
Yeah, I mean, just
Anything.
search for something. Okay, click the view.
Okay.
Anything, go.
Click the view page
Anything.
links.
Existence of God.
Yeah.
Holy shit.
Whoa.
Was this always here?
I mean, no, I edited like today.
That's cool.
What do they say? I can't see.
So like the
Oh.
blue ones are like the outgoing links, and then the green ones which are not here
And
are
then-
like ingoing links. It's one reason to use Moogle, and that's probably the only reason to use Moogle because it fucking sucks.
Oh, page,
Page not indexed.
page
Yeah.
not indexed.
Yeah, I haven't indexed that page. I talked about it. I don't have that many results because I got tired. Like I don't want to like keep scrolling. I just want to finish it before having to continue with the thesis. And that's pretty much it. If you want to try Moogle, you can just go to moogle.app and use it. Don't expect accurate results though. If the code is clean enough by the time this video goes live, you can find everything in my GitHub profile, which is linked in the description. Thanks again. I'll go back to work on my thesis.
Best Fortnite skins ranked. Let's see.
I like how that has nothing to do with Moogle. I'll put it in the video.
It's not. It's really not.
No.
No,
Mine
it's
does?
No.
That is such a shit take.
Yeah, this ranking is cringe.
Okay,
It should remove this page from Moogle. I like Moogle.
thank you. Thank you. I just need
I
to...
will support the project. Oh my god.